Hello and welcome to this Trinity module video. In this video we will showcase and explain how the module Virtual Reality Programming of a Manufacturing Cell works and is set up. In this video we will showcase the requirements to run the system. We will also showcase how to start the system and how to operate the system. So we will individually showcase how each robot can be programmed with this system. Requirements. So to be able to run this module, any VR headset that supports Steam VR, so as long as the headset supports Steam and Steam VR, it will work. In addition, you need to have Steam and Steam VR installed on your computer. You will also need the software Visual Components Premium and Visual Component Experience to run the VR. Now we will explain how to start and launch the VR system. This is done by first starting Steam VR, as you can see here. Afterwards, you press on the VR button, which is in the top right corner. After Steam VR has been launched, you then start your headset and also controllers. Depending on your system, you might also have to set up the cameras for position tracking. When everything has been connected, you can see in the Now Playing window that the camera, controllers, and also in this case, the camera system has been connected since it's lighting up with a blue color. Afterwards, you can launch Visual Components and also load the model where you have created your VR system. And at last, you will load Visual Component Experience and then press on the VR button. This will allow you to connect together the Visual Components model with the VR headset. Now, when everything has been started, take on your VR headset and in the Visual Components menu, use your VR controllers to go into the stream server as shown in this video here. This allows you to directly connect to the simulation you have in Visual Components and connect together your Visual Components experience with the Visual Components simulation. It does also allow you to interact with the robots which you already have. You can also move around in your digital twin copy of your system. This can be done by jumping to points using the VR controller. We will now go through and demonstrate how to program each of the robots we have in our lab, including a Nachi robot, a SCARA robot, a mobile robot, and also a Kuka robot, which is connected to a rotary table. So the Nachi robot can be operated by the control panel, which is on the right side. You can drag the robot arm with its joints with the VR controller to different position. You then press the blue button to add a position to your program. So you can drag it to different points and then press the blue button to add more and more programs. After you have added all your programs, you can press the green button to execute the program you already have created, just to double check that all the movements are okay. You can in addition use the yellow buttons which are on the bottom to customize the positions you already have added. And at last you can press the black button to send this program over to the physical robot if you have connected your digital twin copy to your physical system. In this case, you can see me at the bottom executing the same program I created in VR on the physical robot and running the exact same program on the physical robot. For the second example, we're going to showcase how to program the SCARA robot. In this case, we use the same method for programming where we use the blue button to add a position. But then we can use the purple button to activate the gripper. In this case, we're going to program the robot to pick up the block and then move it to another position. And we also use the same method to move and jog the robot in VR. And in the right-hand corner, you can also see me programming it in real life. After all the positions have been added, we can then press the green button to execute the program. I'll also mention that there is a red button which allows us to delete all positions. And this program can also be transferred directly to the program, to the physical robot, where we can execute the exact same program on the physical robot. In this case, moving down, gripping the block, and then moving to the same position we had in the virtual reality, and then moving down and releasing the part we had picked up. For our third example, we're going to showcase how to program our Kuka robot and rotary table. In this case, this is a quite large robot, which again then requires a large amount of space to be able to program it. You can also jog and rotate our rotary table at the same time when programming the Kuka robot. In this case, the Kuka robot and rotary table are connected together as one part. In this case, we're going to move the robot arm, then move the rotary table and move the robot arm again. And we use always the same control panel as with the other two robots. Then when we're satisfied, we can transfer this program over to the physical robot. And in this case, you can see me live in the right-hand corner executing the same program as I created in VR on the physical system. Being able to execute the program in VR, so in a digital environment, creates a safe method for programming and controlling a system, rather than executing it directly on the physical robot. For our fourth example, we're going to showcase how to program a mobile robot. In this case, we're going to program the Mir 100. So you start the programming by going to the control panel, which is in the corner, and then pressing the blue button to start the programming function. Then afterwards, you just use the VR controller, where you press a button, and that will then generate a yellow marker, which is the place where the mobile robot will drive. When you are programming the system and walking around your environment, the mobile robot will always drive to the next marker you create. In this case, I'm walking around the digital twin model or the laboratory and creating yellow markers at different positions where the mobile robot will drive. After all the yellow markers have been created or where the mobile robot will drive, you can then go to the control panel and press the green button to execute the program and see how the mobile robot will drive. When the movement of the mobile robot is done in the simulation, you can then press the black button to execute or to transfer the program to the physical robot and execute the same program on the physical mobile robot, as can be seen here. When the mobile robot is driving to the different positions, you can see in the top right corner how the mobile robot is planning its routes and that it is actually driving to the same points as has been created in the virtual digital twin model. For the fifth and last example, it is also possible to program all the robots which I already have showcased in one system and one go. There is a separate control panel again for this system. We press the blue button, which allows you to start programming all of the parts. In this case, we're going to program where the mobile robot, it will drive to each robot arm. Afterwards, the robot arm will do a movement, and then the mobile robot will go to the next robot arm. And in this case, we use the VR controller to add a position for the mobile robot, and we use the corresponding control panel to add positions to the robot. In this case, the program, it will be executed in the same order as the system has been programmed. So for this example, the mobile robot will drive to the SCARA robot, SCARA robot will move, then the mobile robot will go to the Nachi robot arm, and then the robot arm will move, and then at last the mobile robot goes to the Kuka robot, and the Kuka robot will do a small movement. This again allows us to program the whole system as one system. Afterwards, we can go to the control panel and press the green button to execute the program in the digital twin environment to see how the program executes. We can in addition move around in the environment while the program is being executed. After the program has been run and everything has been verified, you can press the black button to send the whole program over to the physical system. And we can then execute the whole system in the physical, the same as we did in the digital twin model, as you can see here. In this video, we have shown the requirements for this system and to run it. We've also shown how to start and launch the system. And in addition, we have also shown 5 different examples of how to program different robots with the VR environment. If you are interested in more tutorials on this module or other use cases, please follow the links in the description. Thank you for watching this Trinity module demonstration video.